Today I'll be talking about AI code reviews using Node.js and TypeScript. So I'll be showcasing like a GitHub PR bot, which is going to do the code reviews for you. Okay, a little bit about myself. My name is Raja. I'm a senior software engineer at Loop. It's a car insurance startup. I know I have my LinkedIn up there, but you can grab it at the end of the screen, or also the slides will be available to you on the Commit Your Code website. All right, let's go to the agenda. I'll be talking about the GitHub apps, the AI SDK that I use, a little bit about the architecture of how the flow is built, the demo, and also next steps on what you can do, taking my code and also expanding it into your own things. All right. I think we have all seen this tweet before, like, ask a programmer to review 10 lines of code and he'll find 10 issues, and ask him to do 500 lines and he'll say it looks good. So basically, this is how it will look like if a developer is like reviewing 500 lines of code. This is where I think we can use AI. It does not get tired. It can review 500 or 5,000 lines. It's the same to it. Also, the accuracy also will be good. Unlike us humans, takes us time. It's like a lot of mental drain for us to do 500 lines of review. Now, the code review bot, some of the features, I'm going to just go to the features. It automatically does the review. So you don't have to do anything. The second you create the PR, it's going to does the review and create a comment if it has any bug fixes. Performance insights and auto fix generation. So once it creates the comment, you can ask it to fix it. So it's going to create a new branch with the fix inside it. And also multi-repo support. It's not like fixed to one specific repo. You can use it on multiple repos. You just have one code that handles all of that. The tech stack is Node.js, TypeScript, the AI SDK. You could probably use any other SDK, that's fine. But AI SDK is what I'm using. For the LLM, I'm using Gemini. Probably better to use Claude Sonnet 4.1 or something. And to deploy it, I'm using Cloud Run. You can use any serverless architecture or deploy it on your own machine. Really doesn't matter. Now, why GitHub apps? It's because it provides us with two things. One is trust, and the second is security. Now, trust is where, like, if a user or a developer is using your app, like, your code, the developer needs to trust that, okay, like, this is coming from the right place, and we give it access to the right repo, and also what permissions we are asking from it. So we can set granular controls. In the demo that I'm showcasing, I only gave it access to if a comment is issued or a PR is generated. So only two things, so the developer knows, or the company knows who's using the app, knows that I'm not taking too much data from them. And it's multi-repo support. You can use it on multiple repos all at the same time. And security, JW-based authentications, that's the second part. I don't have to handle any security. You install the app on your GitHub repo, so that part's taken care of. I don't have to handle with any of your API keys. And the biggest one is webhook integration. So whenever an event is created, it's directly going to call my API that's there. So I don't have to manually check that, hey, like this specific repo has a PR created or a comment issued. And coming few details about the AI SDK, it's provider agnostic. So it really doesn't matter which provider you use. You can use OpenAI, Claude. You can use multiple things at the same time. So if it's like something like creative writing, you can use GPT 4.1, or if it's coding, Anthropic. And it gives you structured responses with type safety. So if you're using Zod and you have a type already set up, you can ask it to respond in that specific manner. So if you ask it to write a story and you want a title and a description, and the title needs to be a number, for example, and the description needs to be a string, you already have this type in your React component somewhere else. You can use that same type and use Zod to actually ask the LLM to respond in that specific manner. And also it has streaming support. Obviously, the AI SDK is front-end and back-end. The AI core is the back-end side of things. There's also a front-end SDK which has the UI already, so you can create a chat application probably in like 2 minutes if you use both at the same time. Now, the architecture for the way that it's built is you have the GitHub repo, which has the events that are happening in there. And there's a webhook. It's a simple Express API/webhook is where it's getting called. Whenever any event happens, it's going to call this webhook, and we're going to create like an event filter. So we may get hundreds of events from that GitHub. We don't know what event we're getting. but we have to filter it out. We are only looking for like two specific events. One is when a pull request is open, and the second one is when a comment is created. So let's start with when the pull request is open. When a pull request is open, I'm gonna give that code to Gemini. I'm gonna show you the prompts in a second. I'm gonna ask it to see if there are any bug fixes, any performance insights that it has to do, and reply me back in a markdown format. I'm going to take that response exactly and put it as a comment in the GitHub PR that's there. So I don't have to do my manual changes. It's going to come in markdown format, push it directly. I'm going to use the GitHub API, which I think is called OctoKit. They have like JS, Python, and other libraries with it. So I'm going to post the comment in there. And to apply automatic fixes, let's just say in that same PR, you created a comment saying apply suggestions. I'm going to get that event saying that, hey, a comment is created. I'm going to filter out the comments saying apply suggestions. So I'm going to filter it out saying that this is from me, not from a bot. Anybody could be writing this comment. So I'm making sure that this is actually from a user that's typing it. Once I filter out the comment, I'm going to give it back again to the LLM. I'm going to ask it, I'm going to give the comment to the LLM, the fix that the previous comment has, and both of them combined, it's going to create a file. And we're going to create a new branch, put the file in there, and create a PR from that branch to our branch so that we can merge it, our flow is completed. And use the GitHub API to do the same thing. This is our first prompt, which is like creating like the code review. So you can see that we are saying that you're an expert code reviewer bot. This is important because it sets like the role and the tone for the bot to reply back to you. We're going to send in some details like, the owner, repo, the PR number, title, some of the description, and what files were changed. And we are asking you to focus on two things right here, which is the bugs and the performance fixes. And at the end, if there are any issues, we are showing that, hey, like comment, apply suggestions. If there are no issues, it's not going to comment that. It's just like an extra step that the user knows to actually type this in if he wants the fix. If there are no issues, it's fine. Now, prompt 2 is actually on top of prompt 1. This is where whenever a comment is created to apply these suggestions, what I'm doing is that I'm sending the original files and also the comment body. The comment body was created in prompt 1 by the AI. So it's going to take that in, and we're going to create something called file and file name. We need this in this specific format because this is what we are going to use to commit to our new branch that's there. And also like only include the file that needs the changes. We don't need extra stuff. We don't need anything. We just need what's changed, and we're going to put that directly into our new branch and create a new PR to the new. All right, let's look at the demo. Let me showcase you guys just a little bit of how the bot looks like in the GitHub. So this is how it is. This is the GitHub app. You can give it access to anything. I gave it access to the issue comment and anything dealing with the pull request. You can do push, and there's a lot more events that you can do. Once you install it, you have it. You can see that I have it in my applications. I installed my own thing. You can configure it. Give it access to any repos. I gave it access to one repo. You can give it access to everything. Let me showcase the pull request on how the bot works. All right, let me show you. So I have a bug in this code base. Hopefully, people are able to catch what this bug is in this use effect. There is no dependency array in there, so that's the bug. So hopefully the AI catches it and gives us, let's create this pull request, create. While it's going through that, so we have this GitHub apps, the same thing. You can see all the events that we are getting over here. This is one way to do it. And you can see like, hey, like this is the massive payload that you get. And also you can redeliver it if something got, sometimes it gets canceled, you can redeliver it. Or you can go to your Cloud Run or any webhook event thing and still see the comments that are happening over there. Let's back to code base. There you go. You can see that the bot actually replied back saying, hey, in this specific file, there is a problem that the use effect is missing a dependency array because it's cleanup function. Now it added a comment saying that, hey, like it fixed the code and it just added a comment saying that, hey, like add this empty dependency array. And since there is a bug, it wrote a comment saying apply comment apply suggestions to apply these changes. Let's write that down. Just comment apply suggestions. You can also see that the apply suggestions didn't run when the bot wrote it, because I filter out those events. It's only when an actual user writes this is when we do it. You can see processing your request, AI suggestions, take a moment. Now, if I hover over this, you can see that it created a new branch with the changes that are there and created a PR to our current branch. Let's go click on it. It's also everything is connected, so the PRs are all there. You can see that they're all mentioned in here. If I go look at the file changes, you can see that exact branch. So the change is adding a dependency array over there. So that's like the whole flow of what happens. All right, let's go back. Now, some next steps that you can do with this is, I just showed you the code review process of what this bot can do, but you can generate tests. Like whenever somebody creates a PR, you create a new branch, create tests from it and create a PR to this specific branch. You can update documentation on PR merge. So PR merge is one of the other events that's there. You can be like, hey, like whenever a PR is merged, grab the details of it, create a new branch, create the documentation for it, and create a pull request to your main branch. And going into different, you can add more complexity into this by creating Jira tickets. So whenever a bug is found, you can say that, hey, like go create a Jira ticket and add the Jira ticket in your comment, in the comment that's there. And also you can move the Jira tickets whenever a pull request is merged, move the Jira ticket from like in progress to like done. And scan for exposed secrets, API. Another thing, you can integrate Slack into this. Whenever a bug is found or an API secret is found, you can directly, these are like real-time notifications that users can get through this. And generating release notes from your commit messages. That's one other big thing where whenever a PR is merged or something, you can create the release notes. So now we don't have to do that manually or show the PR and the PR descriptions too. That should be it. Thank you. But I'm going to show the code a little bit so you guys can go through it. Now, you can see that I created this webhook endpoint. This is like a very simple API. It just says webhook. But the GitHub app gives us access to issue comment created. And there's also like a pull request.open. So based on this specific request is what I do. And when you go to, you can see that there are some specific prompts. Prompt is right here, you can put in your code and it's going to generate the text that's there. So it is pretty easy for you to use the code and expand on top of this. And one more question you may ask is how am I going to test my webhooks locally? That's probably the biggest question that everybody has in their mind. I have everything written down in the README file, which is how do you create a GitHub app, which I haven't shown. We didn't have the time to show it, but you have to create the GitHub app, give it access to everything. And for the local development and testing, you can actually use the way that GitHub actually recommends, which is downloading the SME client, target doing this. You can use ngrok. There's also a few other online testing tools that if you just want to get the webhook and test it out, you can do that. Deploying to Cloud Run, you have some access to how to deploy your application to Cloud Run and how to install your bot using the bot. So there's a lot of stuff that I've actually looked through it, common issues. If you have any issues, you should just go through this and you should be able to fix it. Any questions? I think we have a lot of time.
So, say one of the nets I reviews the hardest find code, right? As I'm looking at it, does your AI review ever not catch things because it's AI reviewing AI? You know what I mean?
So that is where I think if you look at this PR, the AI actually hasn't reviewed the code over here. So you can have it in a flow where it's every PR that's generated, fix it, and it's going to go into the flow of because here I just blocked it because the PR is created by an AI. But if you can actually go through a loop where it's it fixes every single time it goes in the loop, create a new branch, fix it. But I created the comment of apply suggestions for a specific reason so that it does not go into a loop. So you have to manually type apply suggestions for it to actually do it. There is an automatic way that I tried out, but I'm like, I don't want it to go through a loop of like trying to fix itself hundreds of times. That's it. There is one point where it does stop. If there is no bugs, obviously, if there is a dependency array already in there, it's going to say like, hey, like there is no bugs. You just stop there. Yeah, go ahead.
I was going to say, how does it perform in that case with more of like architectural issues? If something is more of a code smell than an actual bug, does it still catch those kind of things?
Not the way that I've written it. The way that I've written it is, that's why I said like you can expand it into like multiple things. The way that I've written is I'm only giving it context of my specific PR. But the way that you should work, and billion-dollar companies that are built on this work, is they give context. They'll give a lot of context. What I'm doing is prompt engineering. They do context engineering where they give it, because sometimes the AI may say this is a wrong pattern, but the company patterns are different from the AI patterns. So you have to give it access to it. You have to give it access to your Slack, your Jira, like how much ever context that you can get is what you put into that specific prompt that's there. So that way it can make better decisions on top of it. And you can have like multiple agents working together. So one is like reviewing the code, one is going to generate the code. So you can do it like a step-by-step process and expand on top of this if you want to.
Give an example of that more often is like using that.
Yeah.
All of those certain things like performance issues that are extremely dangerous. How is that?
It is going to catch the re-renders. If you do, I do have like an example of a re-render that happens where it's like a, I think I put like a let me show you. Where it's like a change for, hopefully it's this there. I'm just gonna go through it to see what it is. So here it's like, we are just counting for some specific reason. We are increasing the count when the page renders. They shouldn't be happening, technically, I guess. It's not a performance issue in the sense, but it shouldn't be happening because the count starts from 0. It shouldn't expand to 1. And if I create 1, it should be able to give the review in there. It will tell you what it is. You just have to wait a second. But the way that I've built it is giving you like the simplest example that you can use to like expand on top of it, where, creating code reviews. I feel like most of this, it matters on the context, because performance issues to you may not become performance issues to the LLM or to someone else that's over there. So yeah, I can see that here. Created one, count should start from 0. It removed the use effect that was in there. So multiple use cases for it. It depends upon how much context you're giving it. I just said performance issues just for the sake of it, but you can give it like, hey, get this prettier file, do this specific thing, or get this performance issue. This is what we had before, or give it access to the Jira tickets, which has bugs already inside of it, so it can go through it. There's always use cases to like expanding on top of it. You can use MCPs. Give it access. Like you can use a Supabase MCP and see that, hey, this is giving the wrong response. One of my DB tests is giving the wrong response, and it can connect to the Supabase MCP and actually go through it. You can do natural language with it. There's a lot of use cases that you can build on top of this. Yes. No. It's the way that we built it is not our own specific model that learns by itself. We are just calling like a Gemini or OpenAI GPT that's there. If you want to build your own model that actually learns, I think that's what Cursor does. The Cursor's model, what they do is that every time, it's like a RL program that they do, it learns by itself. Like every time you do a change, it learns. It keeps on learning, but that costs a lot of money because you have to host your own model, keep it learning.
I was also thinking about like the context window as well. Like I imagine with the larger ones, there's like context limitations like with the smaller ones, I guess you can say.
Yeah, that's, if you want to like go into the context window, you have to split it into multiple agents. That's why it's better to split it into multiple agents than use one single one. So if it's just a bug fix, there may be multiple bug fixes. There may be architectural problems. There may be like code problems. There may be like prettier or any other problems that are there. So you can have multiple agents going through it, like, line by line, and giving it context at each stage. It's like, hey, like the pretty is not prettified. Go there, give it context, just that specific context. If it's a bug, give it the Jira tickets or something and say like, hey, go fix this, that specific context. That's where the context window helps. Most of the time, I would say it's not good to even take the full context. Like, I know Cloud Opus has 200K tokens or something. It's not good to take the full context because it may miss a lot of things. There's a lot of details that it may miss, like going through it. That's why it's better to break it down into multiple agents and just go through that flow. Any other questions?
So going back to the model comment, is the way that you built this, is it pretty much plug and play? We could function in our own model, or function in a model can be just replace what you have?
Yeah, the AI SDK allows for that. That's why I'm like, you can use any model that you wanted to do. So I'm using like the GPT. You could use Claude Sonnet. If you want to train your own model in Hugging Face and like try to install that, do it. If you want to connect MCPs, do it. Like I've done like AI SDK with MCP, like Superbase MCP, where you can natural language query the DB. So you can use multiple MCPs inside of this, so that it's like, it's your wish how far you want to go with it. So, but the code base, if you take this, you can expand easily on top of it. It's written in such a way that you can expand on top of it. Any other questions? All right, that should be it. Thank you, guys.
Thank you.